Welcome to my presentation, Genetic Genealogy Yet to Come. My name is Wesley Johnston. In this brief presentation, I will give a high-level look at two technologies that I have been monitoring. One of them is, I believe, a relatively near-term certainty that we will have it. The other is a powerful technology, but one for which I have not yet seen a motivating genetic genealogy application. Here are the topics I will cover. I call the first one photo to DNA or face to DNA, the use of software examining a facial image and generating raw DNA results from it. I think this technology is a near-term certainty for being achieved, not perfectly, but at a reasonably high accuracy level. The second is quantum computing. Quantum computing's potential for genetic genealogy applications specifically. At this point, I see no obvious killer app of genetic genealogy applications that will sufficiently benefit genetic genealogy for quantum computing to motivate a deep effort. But as quantum computing becomes more workable, it is a technology worth monitoring. The methodology for photo to DNA or face to DNA software is a typical machine learning process. In fact, existing facial recognition technology and image coloring technology already do similar work. The process starts by encoding a face, either from a two-dimensional image such as a photo or a painting, or from a three-dimensional sculpture or from live scans of a person. Machine learning then creates a mapping from the encoded face to the raw DNA results that would lead to such a face being created in a person. Parabon Nanolabs and others with existing DNA to face technology that already now generates facial images from raw DNA results has an edge in this step since they have already identified specific DNA and how it maps into a face. The model would learn by comparing how close a face generated from it mapped DNA to the original image. The bottom line at this is that this is very doable with existing technology. In fact, as I will show, one pioneer in this work was published in 2019. So it is highly likely that multiple researchers are now working on just such a tool so that we might see yet another image tool on MyHeritage or some other software in the not too distant future. Let's first take a look at some of the existing technologies. The machine learning process for colorization is typical. Encode the input black and white image and then learn a mapping by comparing to an encoded version of the original image. It is a highly complex task, but one now sufficiently solved to satisfy most uses. Parabon Nanolabs has achieved significant success in generating faces from DNA. The handout contains the link to their webpage that explains how the technology works. The bottom line is that it is very effective, as the comparison of the generated face with the face of the eventually identified person shows in this image. Parabon has a head start on any developers seeking to create face to DNA models because Parabon already has identified the relevant DNA and has the tool to generate a face from the face to DNA output in order to train the model by comparing the generated output and the original photo input in order to minimize error or difference between the two photos. If you have Adobe Photo Elements or Google Photos or any similar tool to organize your photos, you probably have facial recognition software. The method is very similar. The face is overlaid with a grid that is used to encode the facial characteristics. The encoded face can then be compared to a database of other images to find matches. It's a very robust technology now. The same encodings and machine learning processes used for the existing technologies can do face to DNA. Encode the face, learn the mapping to DNA, generate the face back from the DNA, and compare that to the input. Minimize the amount of difference. It is very possible with existing technology, and I would not be surprised if several people are not already working on it. Lest you think this is a pipe dream or something far off in the future, think again. This paper in Nature Communications was published in 2019. It's the only paper I have found. It is not only doable, they did it, albeit to a limited extent. So the technology is coming. What are the implications? Will we soon know the facial DNA of the Mona Lisa or of Michelangelo's David? What happens when someone takes a photo of someone on the street and generates their facial DNA? Will we now have the DNA for the faces of Civil War soldiers? It's time to start thinking about these questions and more. Quantum computing offers the possibility of solving problems that existing classical computers cannot solve. The dreaded application of quantum computing is the one that will make our current data encryption methods useless. Encryption only works because classical computers cannot break the encryption, but quantum computers probably will do that someday. NP-hard for non-polynomial problems are problems that classical computers cannot solve definitively, although some good suboptimal solutions have been found for some problems, such as putting DNA pieces back together in DNA sequencing. The NP means that if you use the classical method of solving the problem, it would require a computer to run for thousands of years. So what are the implications of quantum computing for genetic genealogy? First, it is worth looking at the current state of the art of quantum computing. IBM allows anyone to program very small 5 and 12 qubit quantum computers using their Qiskit program. What it really comes down to is that you have to understand how to configure and use quantum computing gates. Essentially, they are matrix multiplications. For example, the most basic gate is the Hadamard gate, which puts a qubit into superposition or takes a superimposed qubit out of superposition. It's basically a toggle. While you can write programs in Python to do quantum computing in Qiskit, the real quantum computing part of the program is still logic gate configuration and use, which is very low level. So we have a long way to go before quantum computing can be done with high-level programming languages. The bottom line is that the current state of the art of quantum computing is very basic. And even if it was more developed, I do not see any NP-hard genetic genealogy problem for quantum computing to solve. Right now, there is no motivating killer app to make it worth the effort to do a deep dive into quantum computing. Someday that may all change, but for now I see quantum genetic genealogy as a very much over-the-horizon technology. I have written up my exploration of quantum computing and its potential on genetic genealogy. It will be in the next issue of the Journal of Genetic Genealogy and is now on the JOGG website as a preprint. If you do want to look more deeply at quantum computing, the paper is very much worth reading to get yourself started. As I said, this is a very high-level look at these two technologies. I think face to DNA or photo to DNA is imminent, but quantum genetic genealogy is a long way off, even if an appropriate application is ever found.